The owner of the project is the Military Force Technical Authority. The contractor is Orascom. The consultant is Dr. Sabri Samayan Office. The execution of the project started Jan 2014 and it was expected to come to a closing on December 2014. But due to some technical problems during pile drilling, it will be 4 to 5 months late. The bridge will be connecting Katamya access with the ring road Ain al-Sukhna, Nasriti to Heliopolis and the new project of Al-Hizam al-Akhdar. A safety induction was given to our group upon arriving. For any personnel to enter the construction site, one must have or acquire safety boots, helmet, and a refracting vest. Helmets will protect one's head from any imminent accident happening in any way, whether on a scaffold or raft foundation. Moreover, it is great for sun protection. The site layout was basically divided into three components: storage, caravans, and the working area. The land given to the contractor to use for storage and place for caravan is owned by the military forces, and it was given for them till the end of the project. Caravans were divided onto two locations: general caravans for engineers and accountants, and others by the steel cages workshop for quality control. Precast concrete was used in parts that are above operating roads in order to not block it, because sometimes scaffolding is not the best option. Before any execution takes place, the contractor should reach for the Residential Information Authority, asking them to provide for his office the required technical information or drawings to prevent any accidents or problems during the construction process. For example, water, electricity, natural gas, pipes depth. In fact, during this project, the construction company did face an accident during drilling for the piles by hitting a running water line that feeds the whole Katamya residence due to poor quality information. Cages reinforcement. They are 30 meters long, made on 2 to 3 stages of 12 meters to 15 meters maximum each. They have a cover of 7 centimeters. Pile stirrups are installed from the outside of the pile for confinement. On the other hand, piles base top and anchorage length have a steel ring installed from the inside of the pile for better control over the cages while transporting them. Piles drilling. In order to know that one has reached the required depths for a pile, a built-in meter is used within the drilling machine itself. However, other methods, like Maes, is used by applying a weight to the pile hole to acquire the settlement depths of the cage. Drum-eye tubes used when pouring concrete piles. Bentonite is used to keep the hole and the cage free of any soil settlement. As the concrete is at much higher density than the bentonite, by pouring it while the bentonite is already inside, the concrete replaces the bentonite at the bottom of the pile depths. Overflowing bentonite is then treated and reused for other pours on site. Piles testing. After piles are poured and dried, 1 out of 4 piles is to be tested for compression or tension. Compression tests. The pile is loaded with stone blocks by installing secondary beams over the parallel piles. Everything is then loaded on a hydraulic jack. Loads are then added gradually with a rate of 25% per unit time, for instance every 30 minutes, by releasing the hydraulic jack. The settlement of the pile is to be measured. Lastly, the unloading is released gradually too, with the same loading rate. Yet, full load of 200% should be left loaded for 24 hours. Pile to column. After testing the piles for compression or tension, the pile head is crushed and removed by digging around the pile till a specific depth. The reinforcement steel is then opened wide apart, like in a flower shape, to ensure the unity and the interlock between the reinforcement of the pile and the yet-to-be-poured column and foundation. After crushing the head of the pile, every pile has to undergo an undestructive test called ultrasonic test. The pile is to be beaten 3 times using a regular hammer. The technician by that time should have been connected his ultrasonic device to the pile surface. The vibration caused by the hammer are then translated into data on the device screen, showing the loads that the pile can bear into a graph.